Hello again. This is Professor Charles Kaplan, retired. I taught economics and applied math for about 20 years at the undergraduate and graduate levels. I'm putting up these videos to help students worldwide with math and economics. Today, this is the third of probably 4 videos I'm putting up on simplifying algebraic fractions. We started off with easier problems in the first video, a little more difficult in the second video, and we're working on more difficult ones here in the third video. And I guess the fourth video will be a little bit more difficult. And so here we go. Let's jump right into it. How about x squared plus 2x over x squared plus 3x plus 2. So, let's get the numerator. Looks like we can factor out an x there. So it's x times x plus 2, right? Because x times x is x squared, and x times 2 is 2x. And in the denominator, well, we have a quadratic equation. It's a parabola. And we need two numbers. It's going to take the form x plus something times x plus something. And we need two numbers when they are multiplied together equal 2, and when they're added together equal 3. Well, guess what? I think that's pretty obvious that the numbers are 2 and 1. So we have x plus 2, x plus 1. And you'll see, we'll take the first terms, foiling it. Take the first terms, x times x, x squared. The outer terms, x times 1 is 1x. Inner terms, 2 times x, 2x. So 1x and 2x is 3x. And then 2 times 1 is 2. Well, looks like the x plus 2's cancel. And that leaves us with x over x plus 1. Not too difficult. Not too difficult. Now, how about this one? X squared plus 9x plus 18 over x squared plus 6x. Well, I suggest that we factor the denominator first. So let's see, that we get an x times x plus 6, right? X times x is x squared, and x times 6 is 6x. So knowing that we have an x plus 6 in the denominator, looks like we're going to probably have an x plus 6 in the numerator. In the numerator, we need two numbers. When they multiply together, give us 18, and when they add together, when we sum them, they give us 9. I think, again, that's pretty obvious that it's going to be 6 and 3. So we have x plus 3 times x plus 6. So x times x is x squared, x times 6. X times x is x squared, x times 6 is 6x. 3 times x is 3x. 3 times 6 is 18. It gives us x squared plus 9x plus 18 when we group, put together like terms. Okay. So that gives us back what we were looking for. The x plus 6's cancel. And that leaves us with x plus 3 over x. We could actually rewrite that as 1 over x times x plus 3. So either way would work just fine. Okay. Let's see what's next here. Oh, ratcheting it up a little bit I am. 2x squared plus 5x minus 3 over x squared minus 9. Now let's work with the denominator first on this problem. X squared minus 9 is a difference between squares, so x plus 3, x minus 3, x times x, x squared, x times negative 3 is negative 3x, and then inside is 3x, so those terms go out, minus 9. Now, it's pretty obvious we're going to have a x plus 3 or an x minus 3 in the numerator. So we're also going to have a 2x and an x to start us off. 2x, x. So let's see. We need two numbers. When they're multiplied, give us negative 3. And when they're summed, give us 5. But it's not quite as easy here because we have a leading coefficient in this one of 2. So it's also obvious that we need to use 3 and 1. So the question is, which goes where? So we have a plus term in the middle. So here's the thing. 3 times 2, if it's positive 3, 3 times 2 is 6, positive 6. And if this is negative 1, we subtract off 1, that gives us 5. So that's what it looks like it's going to be. We're going to put a minus 1 here and a plus 3 here. So that gives us 2x squared, 3 times 2 plus 6x minus x minus 3. And that gives us, when we combine like terms, 2x squared plus 6 minus 1 is plus 5x minus 3. So that gets us back to what we started with. So now let's take a look what we have here. The x plus 3's cancel, and that leaves us with 2x minus 1 over x minus 3. And that's our answer. Not bad. Okay. Let's take a look at the next one. 3x squared minus 10x minus 8 over x squared minus 16. So again, I think we should deal with the denominator first here. That gives us x plus 4 and x minus 4, since it's the difference between squares. Remember, when we FOIL this out, we have x squared, and then the minus 4x and the plus 4x go out, minus 16. So that brings us back to that. This is one of the easiest factorings you can do, the difference between squares. Now, it's also pretty obvious that, remember, with 8, we've got 8 and 1 and 4 and 2 that we can use when we're trying to factor. But I doubt that we would have an 8 and the 1 in there, being that we have x plus 4 and x minus 4 in the denominator. So we're going to be using 4 and 2 up here in the numerator. So it's also, we need 3x and an x. Okay, so the question is, where does the 4 go and where does the 2 go? We have a minus 10 here. Negative 4 times 3 is negative 12, and plus 2 times x is plus 2x, so negative 12x plus 2x is negative 10x, and that's what we have in the middle here. So it's going to be plus 2 and minus 4. So that's going to give us 3x squared, first terms, when we FOIL. Outer terms, negative 12x. Inner terms, 2x. So negative 12 plus 2 is negative 10, and that's what we have right here. And then minus 8. So the x minus 4's go out, and that leaves us with 3x plus 2 over x plus 4. 3x plus 2 over x plus 4. Not so bad. Not so bad. Okay. Let's see what we've got up next. Well, it may look difficult, but I don't think that it really is. 2x squared plus 17x plus 35 over 3x squared plus 19x plus 20. Now, this one is a step up in difficulty. But think of this. Let's look at the numerator first. We have a 17 in the middle and a 35 here. Now, 35 is 7 and 5. That's it. I mean, it's 35 and 1 or 7 and 5. That's what our choices are. So we're going to have a 7 and a 5. And we're starting off with a 2x. So it's going to be 2x and an x and a 7 and a 5 here. Now, these are both plus signs, so we're going to have plus on both of these. And you know what? 7 times 2 is 14. 5 times 2 is 10, and 7 times 1 is 7. So 5 times 2, 10 plus 7 is 17. So this is going to be plus 5 and plus 7 over here. Now, down here we're going to have a 3x and an x. That's all we can have here with the 3 as a leading coefficient. We have 19 in the middle and 20 on the end. So two numbers, when multiplied together, give us 20. But it's going to be 3 times something equals 20. And when summed, give us 19. Now, look at this. There's no way we can get a 2x plus 7 in the denominator. So x plus 5 is going to be one of the terms down here, one of the terms in our factoring. And it's 4, right? So it's going to be 3x plus 4. So that gives us 3x squared plus 15 plus 4 is plus 19x plus 20. We're good to go. The x plus 5s go out. And that leaves us with 2x plus 7 over 3x plus 4. Not so bad. Looked awful at first, but not so bad. Alright, let's do another here. 5x squared minus 32x plus 12 over 4x squared minus 27x plus 18. This one might be a little more difficult, but let's think about this. For 12, we've got 12 and 1, 6 and 2, 4 and 3. It's usually not the extremes. So I would look for 6 and 2 or 4 times 3 here. We know that 5 has to be 5x and an x for the 5x squared, being that 5 is prime. Let's see. If we use, and we have a negative and a positive here, so these are both going to be negative, right? Because negative times negative is a positive, which we have over here, and negative plus negative is negative. So let's see. Supposing we go with a 6 here, 6 and a 1, 5 minus 6 is no good. But here we go. If we go with 6 here and 2 here, minus 30 minus 2 is minus 32 plus 12. So there we go. We're not going to get a 5x minus 2 out of here. Let's see. 2 and 2. If we go with 6 and 3, that'd be 12, 50, no good. This is going to be a 4x and an x. 6 times 4 is 24, and 3 is 20. This is going to be minus 6 minus 3. 4x times x is 4x squared. 4x times minus 6 is minus 24. Minus 3 is minus 27, and minus 3 times minus 6 is plus 18. Okay, so we factored that successfully. The x minus 6's go out. And that leaves us with 5x minus 2 over 4x minus 3. A little more difficult, but not terrible. All right, let's see. Okay. We have 9 times x minus 5 squared over 12 times x minus 5 cubed. All right, so we have 2 different areas where we're going to reduce here. We have 9 over 12. 3 is the GCF here, so 3 goes into 9 3 times. 3 goes into 12 4 times. Now, x minus 5, well, that's just some number, x minus 5. We're going to be able to reduce the x minus 5s. We have x minus 5 squared and x minus 5 cubed. So, look, if we have x minus 5 squared times x minus 5, that's actually to the 1. That gives us x minus 5 cubed. So this x minus 5 squared goes into x minus 5 cubed, x minus 5 one time. So this leaves us with 3 over 4 times x minus 5. And that's it. That's all there is to that problem. Okay, let's try another like that. 18 times x plus 4 to the 5th over 16 times x plus 4 cubed. Well, 18 over 16, that reduces to, let's see, well, 2, I guess, is the greatest common factor. 2 goes into 18 9 times, and it goes into 16 8 times. So we're going to have 9 over 8. And x plus 4 to the 3rd, that's going to be our greatest common factor. So that goes into itself 1 time, and it goes into this 2 times. So it's 9 times x plus 4 squared. And let me show you why now. Let me show you why. X plus 4 to the 5th over x plus 4 cubed is just x plus 4 to the 5 minus 3, which is x plus 4 squared. And that's what we wind up with up here. Let me show you one other way you can think of that. Let me do that one more and do it this way. Here. X plus 4 to the 5th over x plus 4, what do we have, cubed. Okay. Let's let P equal x plus 4. So we're going to do a little substitution here. So we wind up with P to the 5th over P cubed, which is P to the 5 minus 3, which is P squared. P squared. Okay. So now we back substitute, right? We back substitute x plus 4 for P, and we wind up with x plus 4 squared. So there's another way that we could have done that problem. Okay. Let's see what we've got next. Okay, how about this one? How about x squared plus 2xy minus 3y squared over 2x squared minus xy minus y squared. Okay, so all this means is we're going to have x and y as factors in here. Not a big deal. So in the top one, let's see how we could do this. We're going to have x. Well, we have a plus sign and a minus sign. So we're going to have x plus something and x minus something. So let's see. Well, 3 and 1 are the only two numbers we can use. And since we're positive here, we need the 3 to be positive. And we're going to let the 1 be negative. So if we FOIL this out, we see that we get x squared minus x. Oh, we need a y there and we need a y here. Minus xy plus 3xy is plus 2xy. And then minus 3y squared. We're going to do something similar in the denominator, only here we have 2x and x. And then we have a y squared, so we're going to have a like so. Let me show you why. When we do this, we're going to have 2x squared, and then we do the outer terms. So 2x times negative y is minus 2xy. And then when we do the inner terms, we're going to have xy. So this is going to, when we combine like terms here, we get negative xy. Negative 2 plus 1, negative 1. And that is what we have here, negative xy. So let me rewrite this thing up here. It rewrites as x plus 3y times x minus y over 2x plus y times x minus y. The x minus y's cancel, and we're left with x plus 3y over 2x plus y. So there's our factorization. There's the simplified fraction. Okay. Let's see what the next one's like. Okay. How about negative x squared minus 2x over x squared plus 4? All right. Well, let's factor out a negative x from the numerator. Negative x times what gives us negative x squared? Well, an x. And negative x times what gives us negative 2x? How about a plus 2? Now, x squared plus 4, there's nothing. This should have been a minus 4. And that breaks down to x minus 2 times x plus 2. Sorry about that. Let me rewrite this problem. Negative x squared minus 2x over x squared minus 4. So that gives us negative x times x plus 2 over x plus 2, x minus 2. We have the difference between squares there. The x plus 2's cancel, and that gives us negative x over x minus 2. And there's our factorization for that guy. Okay. Now, let's try this one. 6x minus 60 over x squared minus 20x plus 100. Oh, I could see the way this is setting up. All right, let's factor out a 6 from the numerator. 6 times x minus 10. And in the denominator, well, that's a square, x minus 10 squared. So it's x minus 10 times x minus 10. Take a look. X times x, x squared. Minus 10x minus 10x minus 20x. Minus 10 times minus 10 plus 100. So what do we have? We have the x minus 10s cancel, and that leaves us with 6 over x minus 10. Okay. Let's see what's next here. Well, how about this one? How about, how about x squared plus 20x plus 96 over x squared plus 23x plus 120. Okay. So 96, if you know your 12 times table, you know that it's 12 times 8, and 12 and 8 is 20. So that's how this one's going to factor in the numerator. X plus 12 times x plus 8. X squared plus 8x plus 12x is plus 20x. 8 times 12 is 96. Now in the denominator, it's a little more difficult because what we need here doesn't come up. You don't think of it right away. We have 120 equals 12 times 10. And 12 is 4 times 3. And 10 is 5 times 2. And if we look at these numbers, we get 15 times 8. And 15 plus 8 is 23. And 15 times 8 is 120. So that's what we need in the denominator. X plus 15 and x plus 8. So if we do that, the x plus 8s go out, and we're left with x plus 12 over x plus 15. And the difficulty in this one was factoring the denominator, because 15 and 8 are not two numbers you think of right off the bat when you're thinking about 120. All right. How about this one? 1 minus x squared over x minus x squared. So in the numerator, we've got the difference between squares. So we have 1 plus x and 1 minus x. And in the denominator, we're going to factor out an x. So it's x times 1 minus x, right? Because x times 1 is x. X times negative x is negative x squared. So then we have the 1 minus x's go out. 1 plus x over x. And that's that one. Let's do another one here. How about 2x plus x squared over 4 minus x squared? So we do that. Let's factor out an x from the numerator. We get x times what is 2x? X times 2 plus x, right? X times 2 is 2x. X times x is x squared. 4 minus x squared is the difference between squares. We have 2 minus x and 2 plus x, right? 2 times 2 is 4. The plus 2x and minus 2x go out, minus x squared. So we're going to cancel the 2 plus x's, and we're left with x over 2 minus x. So that takes care of that one. Now let's see. Oh, how about this one? How about 3x minus 21 over 28 minus 4x? So we can factor out a 3, obviously, from the numerator, and we get 3 times x minus 7. 3 times x is 3x, and 3 times minus 7 is minus 21. And we can factor out, it looks like a 4. Yep, that's all we can do there. 4 times, well, this will work out. 4 times 7 is 28. And 4 times what is negative 4x? Minus x. Okay, so we've got this thing again where we need to switch around the terms. So this is 3 times x minus 7. We're going to factor out a negative 1 here. So we've got negative 1, 4. Negative 1 times negative 7, and negative 1 times plus x. So this thing becomes 3 times x minus 7 over negative 4 times x minus 7. The negative 7's go out. We're left with negative 3/4. Bet you never would have thought that you got negative 3/4 out of what we started with, but that's what we wound up with. All right. Let's do 2 more and we'll call it a day. How about this one? X squared minus x minus 12 over 8 plus 2x minus x squared. So the numerator is pretty easy. It's x minus 4 and x plus 3. So the first terms are x squared. Notice I needed 2 numbers when multiplied together give us negative 12, and when added together give us negative 1x. So 4 and 3 come readily to mind, and minus, you're going to have the minus 4 because we're minus x. So minus 4 plus 3 gives us minus 1. In the denominator, we need 2 numbers when multiplied together give us 8, and when added together give us 2. So I think that's going to be 4 and 2. So we're going to have 4 minus x and 2 plus x, right? 4 times 2 is 8. 4 times x is 4x minus 2x. 4 minus 2 is 2. And then negative x squared. Now we're going to have to factor out a negative 1 from this denominator here. Factor out a negative 1 to switch around these two terms. So we have x minus 4, x plus 3, all over negative 1 times negative 4 plus x times 2 plus x. That's going to give us x minus 4 times x plus 3 all over negative 1 times x minus 4 times 2 plus x. The x minus 4's go out, and that leaves us with x plus 3 over negative 1 times x plus 2. And if you wanted to, this is perfectly fine. If you wanted to, we could do negative x plus 3 over x plus 2. All right, let's do one last one. Make it a good one. How about 5x minus 40 over 80 minus 10x? So from the numerator, let's factor out a 5. So we get 5 times x minus 8. 5 times x is 5x, and 5 times minus 8 is minus 40. And from the denominator, let's factor out a 10. So we get 10 times 8 minus x. Well, we're going to have to flip around this denominator. Now, first notice, well, I'll get to that in a bit. Let's take care of the factoring out of the negative 1. So I'm going to do this now. 5 goes into 5 once, into 10 2 times, so we can reduce the 5 over 10. Okay. So we're left with x minus 8 in the numerator. And then we're going to factor out a negative 1, so I'm just going to add that negative 1 to the negative 2 over here, okay? So I'll do it this way. Negative 1 times 2 times negative 8 plus x. And that becomes negative 2 times x minus 8 over x minus 8. These two guys cancel, and we're left with negative 1/2. And I'll bet you never saw that coming when we started with this up here. That doesn't look like negative 1/2, at least not the way it is. I can see how it got that way, but okay. Well, this is Professor Charles Kaplan, retired. Taught economics and applied math for about 20 years at the undergraduate and graduate levels right here in New York. I'm putting up these videos to help students worldwide with math and economics. If you need a private tutor, I'm also available through Wyzant, W-Y-Z-A-N-T, online, under Charles Kaplan, K-A-P-L-A-N. So that's it. I hope you found the videos helpful. This is the third or the fourth one I think I've done on simplifying algebraic fractions. So you can find the other 2 or 3 up there on my main page for my YouTube videos. And that's it. I hope you have a happy, healthy day today, and that you have a great life. That's it. Bye-bye.